Alright, are you ready for this one? This is number 51. Okay, it first says make a drawing. Okay, well, we have a runway here that is 9,000 feet. We have a plane up here that's flying. There. And we have a couple angles to it. This first angle comes from the near side of the runway. The second angle comes from the far side of the runway. Okay, and these angles are taken from the horizontal, so I'll just draw that line in. The first angle is 18.8. The second angle is 17.5. Okay, and then the first, so you have to draw it first. That's part A. Part B says, if I have a triangle here, what is the hypotenuse of that triangle? Because it says find the air distance. So the air distance would be from here to here, the hypotenuse of this triangle. Okay? So how do we do that? Well, we need to take this little sliver of a triangle inside, and I'll just make it a little bit bigger down here, but it looks something like this, with 9,000 on the bottom, 18.8 here, and 17.5 here. Knowing those values, I can find this angle inside by just subtracting 18.8 minus 17.5. And I get 1.3 degrees. So the sine of 1.3 degrees over 9,000 is one of the ratios I can use to find the rest of this triangle. But I'm going to need at least one more angle or one more side. I cannot find one more side, but I can find an angle. Okay, let's go back up to the original drawing. It might be easier to see. This red line on top and this brown line on the bottom are parallel. Okay, if they are parallel, it means that alternate interior angles are going to be congruent. So if this angle here is 18.8, this angle down here is also going to be 18.8. I'll let you pause the video and see if after that hint you can solve the rest of the problem. Okay, well, hopefully you did. Pause the video. So what we just found was this angle out here is 18.8, which means we can find that angle inside. We're going to take 180 minus 18.8. If I do that, I get 161.2. Okay, so what we need though, because we're looking for this side here, we need this angle. So I'm going to take 180 minus 161.2 minus 1.3. And I get 17.5 degrees. That would be this angle right over here. And I guess that makes a lot of sense. We could have just used alternate interior angles. But I guess we just proved that for ourselves, right? Because here's this angle. Here's this line down here. These two lines are parallel. Here's a transversal. Alternate interior angles. So we did one extra step, I guess. But we're going to need that angle later anyways. Okay, so 17.5. So to find x, the x I have up here, which would be the answer for B, we would take sine of 17.5 over x. So 9,000 times sine 17.5 divided by sine of 1.3, and I get a big number. I get 119,289.1, and this is in feet. So I think I'm just going to change it to miles by dividing by 5,280. So divide this by 5,280, and I think that's what the book did, and they get 22.6. Okay, I'm going to save this now. I'm just going to save it as X because that's what I call it. Actually, I'll save it as B. Okay, find the ground distance the plane must travel until touching down. Okay, the ground distance would be this triangle here. If this distance is that 26 we just found, Now I can use cosine of 18.8 should equal, we'll call this C because that's the part it is in the problem. So I'm going to go C over this value I just found of 26. Okay, so I'm going to take 26 times cosine of 18.8, and I get 21.4. Okay, 21.4 is what C equals down here. And lastly, find the altitude. Well, now I'm just going to use Pythagorean's theorem. So I'm going to store this as C, and I'm going to take B squared minus C squared, because I have this value stored as B, I have this value stored as C, so B squared minus C squared, and then I'm going to take the square root of that, and that'll be what this side equals. And if I do that, I get a value of 7.3 miles, miles, and miles. 26. That's not 26, it's 22.6. Hope you guys weren't using that value. I've been writing it down, but it's 22.6. This should be 22.6. Alright. Alright, that's what I had down here. Alright, hopefully you're able to, I was kind of rushing through this one because I got to go, but hopefully you're able to follow along.